Hello everyone, this is Amita from AIDS department. Now we are going to see about half and full subtractor. First we can see about half subtractor. Half subtractor. The half subtractor is constructed using XOR and AND gate. The half subtractor has two input and two outputs. The outputs are difference and borrow. The difference can be applied using XOR gate. Borrow output can be implemented using an AND gate and an inventor. Input and output variables. Input variables are a and b. Output variables are s is equal to sum and c as carry. This is the truth table and the circuit diagram. If we give input 0 and 0, the borrow would be 0 and difference would be 0. If we give input 0 and 1, borrow is 1 and difference is 1. If we give input 1 and 0, borrow is 0 and difference is 1. If we give input 1 and 1, the borrow is 0 and difference is 0. This is the K map. List of components. 2 input AND gate. The IC specification number is 7405. 2 input XOR gate 7486. 1 NOT gate IC 7404. 2 input OR gates IC 74032. Now we can see about full subtractor. Full subtractor. The full subtractor is a combination of XOR, AND, OR and NOT gates. In a full subtractor, the logic circuit should have 3 inputs and 2 outputs. The two half subtractor put together gives a full subtractor. The first half subtractor will be C and A, B. The output will be difference output of full subtractor. The expression AB assembles the borrow output of the half subtractor, and the second term is the inverted difference output of first XOR. The input and output variables. Input variables are A and B. Output variables are borrow and difference. This is the circuit diagram. This is the truth table for full subtractor. This is the K map. The components we required are 2 AND gate IC number 7408, 2 XOR gate IC number 7486, 1 NOT gate IC number 7404, 2 OR gate IC number 7432. This is half subtractor. Place 3 switches for as input. Put an 2 XOR gate, 1 AND gate, 1 NOT gate, and two bulbs as outputs. Now we can start labeling. We label the switches as A and B, and then label the gates as XOR, NOT and AND gate. and label the output bulbs as borrow and difference. Let's start connecting. We can connect the switch A to the XOR gate and switch A to the NOT gate and switch B to the AND gate, switch B to the AND gate, then switch B to the XOR gate and the output of NOT gate to AND gate, and the output of XOR gate to difference, and the output of AND gate to borrow. Now if we switch on the light B, the output is 1 and 1. If we switch on the light A, the output is 1 difference and borrow 0. If we switch on both light A and B, the output is difference 0 and borrow 0. And if we switch on the only light B, the difference is 1 and borrow is 1. Now full subtractor, we can place 3 switches. One XOR gate, one AND gate, one NOT gate, another one NOT gate, another one AND gate, and another one XOR gate, and one OR gate. And bulbs for the outputs. And now we can start labeling. We can label the first switch as A and the second switch as B, and the third switch as borrow. This is borrow input. And then labeling the gates. XOR gate, this is XOR gate, and this is NOT gate, and this is AND gate, This is not gate. This is AND gate. This is XOR gate. This is OR gate. And naming the output as sum, difference and borrow. The first output as difference and the second output as borrow. Let's start the connection. Connecting A switch to XOR gate and a switch A to NOT gate, and connecting switch B to parallelly to the XOR gate, and connecting switch B to AND gate, one of the AND gate, first AND gate, and borrow in to the second XOR gate, and another borrow in to the second AND gate, and output of NOT gate to the AND gate, and output of XOR gate to the NOT gate, and output of XOR gate to another XOR gate, and the output of NOT gate to AND gate, and the output of AND gate to OR gate, and the output of first AND gate to the OR gate, and the output of last XOR gate to the difference, and the last OR gate to the borrow output. Now if we turn on the switch A, the difference is 1 and the borrow is 0, and if we turn on the switch B, the difference is 1 and borrow is also 1. And now if we turn on switch A and B both, the output is difference 0 and borrow 0. Now if we turn on switch A, B and borrow in, the output is difference 1 and borrow 1. That's it. Thank you.